So hi everybody, thanks for being here. This is the last talk of the day, I know you must be tired. I hope you still have some energy left and that we will enjoy this talk. So this will be about digital signature in blockchain and how we're using it at DocuSign. I will begin by introducing myself. My name is Cyril Thirion. I'm working at DocuSign as an engineering manager. And for those of you who don't know what is DocuSign, so it's a SaaS company that enables you to digitally sign documents, no more paper needed. And I started my professional life in all the PKI, digital signature, SSL certificate world. So it has been a long time. And currently my team is working on two main subjects, compliance with European regulation and identity verification. I wanted to just explain you what it's not about. This will not be a detailed presentation of the blockchain and how it works. It's rather about how could we use the blockchain in a digital transaction, where it could make sense. Let's start with the agenda. First of all, I will define what is a digital signature as defined by the European regulation, eIDAS, for those of you who knows what it is. Then I will do a quick reminder of what is a blockchain, not going into a lot of detail, but quick reminder to have the basis. Then we will talk about value of using the blockchain in digital transaction. And finally, I think an important point, asking ourselves if the blockchain is always the best solution. So I apologize, it will be the legal part of the presentation, so maybe a bit boring, but this is really important because it drives the technical implementation of the digital signature. So eIDAS is a European regulation from 2014 that you can read online. It's public, so if you have time during the night, you can check out the regulation. But what is really important is that eIDAS is defining 3 levels of signature, and let's go see them. The first one is a simple signature. So a simple signature is like a handwritten signature applied on a digital document. So we have a digital document, I applied a handwritten signature, and this is a simple one. I guess most of you already done something like that, and obviously it's really easy to fake it, so that's why we have a more advanced signature. The advanced signature needs to meet the following requirements. First of all, we need to be sure who signed the document. For that, we will use, for example, two-factor authentication, OTP SMS, or something else. Then we need to make sure that it's the right person that is in front of the computer and the right person that will sign the document. For that, we could, for example, ask him to show his passport or something like that. Then the signer needs to agree and understand that he is signing a document. So it could be a simple thing like using a checkbox, but this also means it can't be done automatically through API. We can't automatically sign document through API. I know some people ask us that at the booth, but it's not possible due to the regulation. And finally, we should not be able to change anything in the document after the signature. I guess you can easily see why. Okay, already at this point, if you know a bit about the blockchain, I think you can see the link, especially with the last point and the blockchain, the immutability of the blockchain, and obviously we will come back on it. And last one, the qualified signature. So this is the most advanced one. I will not read this slide, just to show you that it needs to meet a lot of requirements. Same thing, there is online requirements. Something you can maybe notice is it's really related to all the PKI stuff, infrastructure. And also, it's really heavy for the signer in terms of process. If there is some Belgium guy in the room and you have EID, yes, the Belgium EID is a qualified certificate, so you can do qualified signature with it. Okay, that's all for the legal part. Now that we have defined what is a signature, let's talk about, well, the blockchain. Quick reminder. The blockchain, basically, it's a chain of different blocks. And all blocks are chained together by their hashes. So a block is, there is a lot of metadata in the block, and we have the hash of the block. And the next block is referencing the previous block, so blockchain. Some maybe well-known blockchain. Here we have the Bitcoin and the Ethereum. And you can see, so online, publicly, you can see some information about those blocks. So we can see, for example, the number of the block. This is a height, so you have the ID. You have the generation of each block. So you can see here that well, the Ethereum blockchain is generating block faster than the Bitcoin. The implementation is different. Then you have transactions that will be attached to each block. So we'll see that later. We have the name of the miner, so the one who created the block. And finally, well, the size of the block. If we go into more details about what is a block, we can retrieve the same information, the number of transactions, the ID of the block, which is number of block we have, and the link with the previous block. And you also have additional metadata at this point. So as you can see, one thing that is really interesting is that we have number of transactions. It means inside the block, you could have a lot of transactions that will be tied to this block, and this will help us later. So we will have an example. We will come back on that. Just to give you an example of what is a transaction, it could be, for example, A is giving some Bitcoin to B. This is a basic transaction. Ethereum blockchain, same thing. We have the same information. It's a blockchain, so it works pretty much the same way. Now that we've saw what is a block, let's see how the block works together in a network. So you may have already heard the term distributed ledger, which means that every node of the network have a copy of the ledger, and basically anybody part of the network can create the next block in the blockchain. The faster to create the next block win the competition, and can share the block information to the whole network. Now you may wonder what happens if there is two computers that is creating the next block at the same time. In that case, you could end up with something like that, meaning two blocks reference the same parents. And in that case, the blockchain will choose the longer path as the source of trust. So it means, why is it important? It means that if you're pushing transaction inside the blockchain, you need to wait several blocks to be sure that your transaction is well recorded in the blockchain. So this will be also important, that you need to wait, and especially with a Bitcoin, as you have a new block every 10 minutes, so you could wait, for example, a day to be sure that your transaction is well written in the blockchain. Last thing I wanted to talk about for the blockchain is that we have two main types of blockchain. On one side, we have the public ones. So a public one is pretty easy. It's like Ethereum or Bitcoin. There is lots of other blockchains. Anybody on internet can have access to those blockchains. As you can see, we can see what is inside the blockchain. We can contribute to the blockchain. We can be a miner as well. Well, we need more than just a laptop, but anybody can be a miner in this blockchain. And anybody can read all the transactions that happen. So transaction, it will be A is giving some money to B, and we are talking about addresses, so we don't know who that is, but we can read who giving money to whom. On the other hand, we have the Ripple blockchain, for example. There is other as well, that are private or permission blockchain. And those blockchain are mainly internal blockchain into an entire system. So for example, for the SEPA mandate, when you want to transfer money to someone else in Europe, all the banking systems are using a private blockchain to exchange information between the banks. And obviously this is not public, and you can't read what is inside it, so everything is encrypted, but the protocol and the technology behind is like a blockchain. Okay, so we've talked about digital signature, we've talked about blockchain. Now the main interesting thing, let's see how they can work together. I saw on internet some people wondering, well, can we get rid of certification authority, especially for HTTPS certificates, because you need to pay a company to issue certificates, and it's kind of, well, you don't want to pay someone. And digital signature are really close to HTTPS certificates, so I think it's really interesting to see kind of the difference and, well, what we can do with that. Okay, so how a document is signed. Maybe some of you already came at our booth, so you may have already seen a live demo of how DocuSign works. So someone in DocuSign, someone will send a document for signing to someone else, and from a signer point of view, this would be the workflow. So I will receive a document for signature, and the first step will be to identify myself. So like I said before, in compliance with eIDAS, I need to identify the signer. So I will have to upload a passport or a copy of my ID. You could also use a system like It's Me, this kind of thing. Then, once you identify on DocuSign, on the portal, well, you will fill the document. And the other interesting part is what we are calling the trust service provider. So when you're clicking on signing, behind the scene, a lot of things happening. We will take your identification information. We will take the hash of the document. So we will calculate the hash of the document. And we will send that to a trust service provider. A trust service provider is kind of the same thing as a certification authority. So this trust service provider will be in charge of generating a digital identity for the signer, sign the hash, and return the hash signed to us. And then, well, using the PDF standard, we will digitally sign a PDF. Okay, so this is all to be compliant. Now, what could the blockchain solve? No more centralized source of truth. So today, how a signature is verified once a signature is done on the document. So if you're opening a digital signature on a PDF document, and you're asking, for example, Adobe Reader or any other software to validate your signature, you will end up with something like that. So this is all inside the metadata of the PDF. We have the name of the signer of the document, in that case me, well, the time the document has been signed, and the certification pass. So the certification pass is the reference for the creation of this digital identity. So in that case, the digital identity that has been created for me, we have all the chain of certification authorities that created this identity. This is exactly the same as HTTPS certificates. If you're familiar with that, it's working exactly the same way. And you have the trust point. So a digital identity has been created for someone, but the question is, how do you trust this digital identity? The answer is, you need to trust something. And in that case, you are trusting a certification authority. So this one is trusted by Adobe and European regulation. So this is your trust point. Okay, today at DocuSign, so DocuSign is a certification authority. So we are kind of holding the truth of your identity. Well, we are holding the truth of your identity. We are keeping all the proof inside our system. And here is why. Here is how. So you have the European trust list. So it's publicly available, same thing. Europe is trusting countries, and countries are trusting private company, or could be also government, to issue digital identity. So you can go online, check for countries, and see the certification authorities that are trusted. And we are in the French trust list. So the certification authority will issue a digital identity that will allow you to sign a document. And so it could be either a one-time certificate, or it could be a digital ID, like a smart card, like you have in Belgium, for example. So the problem with that is that the CA has everything. And if the CA is compromised, or if something happens to the CA, well, you're kind of losing all the truth around all the trust around the digital signature. So this is where we could say maybe we could have a distributed ledger that will keep the proof around everybody instead of just around the one CA. So let's see what would happen if we replace the certification authority by, let's say, one blockchain. I took Ethereum, but could be another one. So in that case, the workflow at the beginning will be the same. We will identify using whatever, passport, ID, and then we will send the identification information and the hash to the blockchain instead of to a certification authority. It means we will publish everything to everybody, and everybody can read and trust the network. So that seems like a good idea at the first thought. But there is some issue with that, obviously. The first one is today at DocuSign, just to give you an example, 71% of our documents are signed in less than an hour. And as you remember, to create a new blocks in the blockchain, it takes time. And it would mean that we would have to wait 2 or 3 hours maybe to make sure that your transaction is written in the blockchain and to be able to go further with your document. Especially if you have like 5 signers that need to sign a document, well, you're losing a lot of time just waiting to make sure that the blockchain is working properly. And there is also something else. You may have already heard of it, GDPR. So GDPR, European regulation around data privacy, PII, personal information. If we send all the information to the blockchain, we have to send the identification information because this is part of the trust. This is how you identify the signer. And if you push all that to the blockchain is immutable. You cannot delete a block or change a block after it has been done. So it means it's inside the blockchain forever. So if there is personal information, it's inside the blockchain and you cannot get rid of it. Today, if you have a certification authority, you could ask them to purge everything they have on the envelope because, for example, the contract has been signed 10 years ago and it has no value anymore. So you could ask the certification authority to get rid of everything and you will end up with something like that. So all the email, name, everything is deleted from all the system. And this is something you can't do with the blockchain. So this is, okay, this is not really a good use case for the blockchain. This is why we thought about another use case. Going beyond just the signature. So today, digital signature simplify the signing process by making it digital, so it's really faster. Once the document, meaning instead of printing, signing on paper and scanning the document back, it's just, as we've seen, a couple of minutes, hour maybe, and it's done. But the problem is, usually after the signing, while we are coming back to a, I would say, manual process, usually there is things that needs to be done after the signing, and it's, well, it's pretty often it's manual. For example, we can take an example. So at Devoxx there is sponsor, and let's say so Devoxx needs to sign a contract with a sponsor. So Devoxx will send the contract through DocuSign. The sponsor will receive the document, sign. So it will be easy, especially if the sponsor lives, I don't know, far away. really faster than sending it by the post. And once the contract is signed, it goes back to Devoxx. But the problem is, after that, I guess Devoxx has still a lot of things to do. The contract is signed, sure, but maybe they have to wait for the payment. They have to, I don't know, they reserve a booth for the company. They have to send some information to third parties for the, I don't know, printing the logos on some white paper. There is a lot of stuff, and today, I don't know, but I guess a lot of those things are done manually. So we can wonder, well, does the blockchain can help on these parts? And the answer is mainly, at least you can try. So if you know a bit about the Ethereum blockchain, one thing that is really interesting with this blockchain is that you can add code inside the blockchain. So what does it mean? It means that when you will send a transaction inside the blockchain, it will be what is called a contract or a smart contract, which is basically code that will be written inside the blockchain. So the code, this is a code sample that could be sent. And it's publicly available. Anybody can read this code, and that's why you need to be careful, because if you have a security issue in your code, well, anybody can see it and exploit it, and you cannot change it after it has been published also. So for example, with this code, well, we have three properties: the owner of the contract, a boolean to say if the document is the signing complete or not, the hashes of the document, just to have a list of all the hashes, and then, well, it's a Solidity language, but it's, well, it looks like well, it's a language anyway, so you just have to learn it, then learn the syntax. So we have three function and the constructor. So in our use case, when you send a document to signature with DocuSign, DocuSign will create this contract and send it to the blockchain. So DocuSign will be assigned as the owner of the contract because he's with the constructor, and DocuSign is sending it. And then every time a document is signed, we could, for example, add the hash of the document inside the blockchain. We could also imagine that third parties could add hashes inside this blockchain. So for example, if at some point DocuSign is calling a third party because we are relying on we have a payment that is done inside it, we could use, so the payment system could also push information inside this contract. And everything will be tied together inside the blockchain. Once everything is completed, for example, we could say call the function complete envelope. In that case, we ensure that only DocuSign can call this function, nobody else. And last, we have a function which is called isEnvelopeCompleted that will return the Boolean and the hashes of the document. One thing you may have noticed is that the last one has a keyword which is constant. So what does it mean? The blockchain, obviously, it takes resources to build the blockchain and to contribute to it. So when a miner mines a block, he gets a reward for this mining. Maybe you know about that, especially with all the Bitcoin stuff that happened lately. But so the miner gets a reward. It means in order for the blockchain to work, it means that when you're doing things with the blockchain, you have to pay for it. So you're paying in Bitcoin or in Ether for the Ethereum blockchain. And all function cost some money, except the kind of read-only function. So that's why we have the constant keyword. That means if you call this function, it's free. But if you call any other function, it's you have to pay in Ether. So as we said, the blockchain is public. Anybody can have a look at what is a blockchain. So previously we've seen a view of the blocks, different blocks, but we can also have a view that is tied to a contract. So in that case, we see that, well, first element is the creation of the contract, which is the last line. So we have the transaction ID. We know in which block this contract has been written, when, and who asked for the creation of the contract. In that case, well, it's all DocuSign addresses, but could be other as well. After the creation of the contract, we can see that we've called the add hash function. So we would have to go into the detail and look at it, but we have the add hash function. And finally, the envelope complete function. So anybody could have a look at that, and anybody also could call the isCompleted envelope and act on it. Also, in the contract, we could imagine that, so right now this is a fixed contract that we've done, but we could, when you send the envelope, we could imagine that the sender will be able, or an admin of the account maybe, could write some custom code here in this part of the code, which means that when the envelope is complete, maybe we could have custom action that would be started. We did maybe some of you have seen on the internet, but we did a POC with Visa, where, so it was not this contract, but where when a contract for insurance was signed, and when the payment was done on another side, when everything was published to the blockchain, we could start basically start the contract. Meaning the insurance will start at the date of when the contract is signed and the payment is received. And this could be done here. So this is, today it's mostly proof of concept of that. So we are not publishing everything to every envelope information to the blockchain. We will only do it for proof of concept. But yeah, this is a typical use case. And so we are wondering, today, as I said, blockchain is mainly proof of concept. There is a lot of things that could be done, but there is really a question around that is, does the blockchain really help? Meaning, sure, it can help, but it has a cost. And the question is, does the cost really worth the investment? As you can see, we can execute code, we can do a lot of things, but we could also do that through APIs. Especially with the identification part, the first point of the presentation, we've seen that it may not be really interesting to use the blockchain for everything. Maybe in some cases it could make sense, but we need to be very careful. Two things we are really looking at is using the blockchain for identity. There is things that are happening, especially with the Hyperledger technology. That is, I think, IBM is behind it. So the idea of this is to have your digital identity on the blockchain instead of having a smart card or something like that. And we could imagine using that to authenticate to DocuSign. So this could be one use case, but always we need to make sure that it's really worth the investment. For the second one, the second use case, where with the smart contracts, so the same thing, we'll keep following the evolution, but today it's not really in production because there is no real use case yet where it's really interesting, but we are still looking at it and see if there is some stuff that can be done. So my last point of the presentation, and coming back to the agenda, is the blockchain always the best answer? And the answer is, I think, no. It could solve some issues, but it's not the answer to everything. Pushing information to the blockchain costs. Also, creating new blocks costs a lot, especially in terms of energy. We have some global questions today around that. So, is the blockchain always the good answer? Well, maybe not. The blockchain could solve some issue, but we really need to use the blockchain really wisely, I would say. And yeah, that would be my last word for this presentation. Be careful with the blockchain. So if you have any question, you can send me an email or ask your question.